So we are into solving two-step equations. This is probably the skill in algebra you need to have down the most, if nothing else, is this one right here. So we're going to work on it a lot until it's really, really easy for you, and then when you move on into IM1, it'll be piece of cake. So you already know that every operation has an inverse operation. So addition and subtraction are opposite from each other. Multiplication and division are opposite from each other. Eventually you will use things like squaring and square root. We've already touched on that a little bit. And we'll add those in as we go. So if you look at an equation, remember that the goal is you have a letter equals a number, right? That's always our goal. So when you get an equation that looks like this, something's happened to that x. And so your job is to figure out what's happened and then undo that. So if we look at this problem here, x was divided by 2, and then it had 3 added to it. So when we solve this equation, we're just going to reverse those two functions and reverse the order we do it in. So the first thing we're going to do is subtract 3, because that's the opposite of adding 3, and then we're going to multiply by 2. So we're going to subtract 3 from both sides, so that would give us x over 2 equals 16, and then I'm going to multiply both sides by 2, and that would give me 32. Whenever you solve one of these equations, you are always going to plug your answer back in to double check it. So now instead of x, now I have a value of 32. So I have 32 divided by 2 plus 3, and if I'm correct, that should give me the answer I have on the other side. Well, 32 divided by 2 is 16, and if I add 3 to that, I get 19. So that is correct. Okay? So every time you look at one of these equations, I want you to just think about, there's my variable, what happened to it? And it actually helps if you, for a while, just write it down. So first, it was divided by 2.5, and then it was given by addition 3.2. So now we're going to reverse the direction of that and use the inverse operations. So we're going to subtract 3.2 and then multiply by 2.5. So let's go over here and do that. So we're going to subtract 3.2 from both sides. And that undoes that operation, so that cancels out. So now you have x over 2.5 equals 4.6 minus 1, or sorry, 3.2 is 1.4. And then we need to undo dividing by 2.5, which means we're going to multiply by 2.5, which undoes that operation, and now you have the variable isolated, which is what you want. So 2.5 times 1.4, let's figure that out. So that's that. We need to pull those decimals back too, so that's 3.5. And of course you're going to plug that in and check your answer on that. So we have our solution of 3.5. Okay? So remember again, I want you to have a variable on one side and numbers on the other side. And if you decide which side they're each going to be on, it doesn't matter. You can have numbers on the left-hand side and variable on the right. It doesn't matter as long as you end up with a variable equals a number. Because you're just finding a missing value when you're solving an equation. Okay, so in this first one, f had 2.5 added to it. So it had 2.5 added, and then it was divided by 3. So we're going to switch those around, and the first thing we're going to do is multiply by 3, and then subtract 2.5. So we're going to multiply both sides by 3. That undoes that operation. That gives us 6. And then we're going to subtract 2.5. So that undoes that operation, and we get 3.5. Okay. If you plug that back in up here, you would have 3.5 plus 2.5 divided by 3. That gives us 6 divided by 3, which equals 2, which was our original solution. Okay, I want you to try these two on your own, and then come back and check your work. So again, here, the two things I have to undo are first it had 1 subtracted from it, and then it was divided by 7. So we're going to do the opposite, which is to multiply by 7 and then add 1. So I'm going to multiply both sides by 7. That gets rid of that, so now I have x minus 1 equals 7, and I need to add 1 to both sides, and that gives me x equals 8. I can go back and check this. 8 minus 1 divided by 7 is the same as 7 divided by 7, which equals 1, and that was my original answer. Here, first, r was being multiplied by 16, and then had 12 subtracted from it. I'm going to switch those around, add 12, and then divide by 16. So I'm going to rewrite that equation. I'm going to add 12 to both sides. That undoes that. I get 16r. Negative 4 plus 12 is positive 8. And divide both sides by 16. And r, I'm going to reduce that and get 1/2. I'm going to go back and check that up here. So instead of r, now I have 1/2. Well, half of 16 is 8. Minus 12 is negative 4. And that is true. So I know I have the right solution. When you're solving one variable equations, there is one and only one solution to an equation. So if you can plug that answer in and get that answer on the side where the number is isolated, you know you have the right solution. Okay, so here's a good place where I use, you kind of have things mixed up. So this is combining like terms again, but we're going to move things over to their appropriate side. So think about the analogy I use of the produce being sorted out at the grocery store. So you need to have x's on one side, numbers on the other side. So let's just choose which one is going to go where. So I'm going to have x's on the left-hand side and numbers on the right-hand side. And then I'm going to look at each term and decide whether it needs to stay, if it's in the right place, or if it needs to move. And if it needs to move by the opposite function. Okay? Move by performing the opposite operation. We can call it function. Okay. So adding, subtracting, multiplying, dividing. Okay, so this is a variable 2x. That's going to stay where it is. Negative 14 is a number, so I'm going to move it to the other side. So that's going to give me positive 14. 4 is a number, so I'm going to move it to the other side. The opposite of 4 is negative 4. So these can go. Now I just need to total that up. So I have 2x equals 10 plus 14 is 24, minus 4 is 20. And then x had to multiply to it. I need to divide that back out, and I get x equals 10. I'm going to go ahead and check my work. So I have 2 times 10 minus 14 plus 4 should equal 10. Well, that gives me 20. Negative 14 plus 4 is negative 10. And 20 minus 10 does equal 10. Okay, same thing. You can move the variables to the other side. And in fact, I'm going to do that on this one. I'm going to keep the numbers here and the j's on the right-hand side, just so you can see that it doesn't matter. So 2j is a variable. I'm going to move it over here by negative 2j. Negative 4j is a variable. I'm going to move it over here by positive 4j. 10 is a number, so that's good right where it is. 12 is a number, so I'm going to move it to the other side by subtraction. So anything that got moved, we can cancel out. And now we've got numbers on this side, variables on this side. I just need to total them up. So 10 minus 12 is negative 2. And negative 2j plus 4j is 2j. I'm going to divide both sides by 2. And I'll get negative 1 equals j. I can go ahead and plug that back in my original equation to double check that. So 2 times negative 1 would be negative 2. Negative 4 times negative 1 would be positive 4. Plus 10 should equal 12. So 10 plus 4 is 14. Minus 2 is 12, and that answer is correct. Okay, so sometimes you will do these in word problem form too. So the output of a function is 8 more, so we don't know what the output is. We don't know what that is. The output of a function is 8 more than 3 times the input. Find the output when the, find the input when the output is negative 1. Okay, so we know the output. The output is -1. Is means equals. 8 more than, so 8 more than 3 times, and we don't know what the input is, so that's what we're trying to find. So we're going to call that x. You can use whatever variable you want. 8 plus 3x. So now you're going to use your method that you have. Since the x's are already over here, I'm going to leave them there, and I'm just going to move anything that's a number to the other side. So numbers are coming over here, variables are staying there. So -1's fine, it's a number, it can stay there. 8 is a number, it's got to move by the opposite, which is -8. 3x is fine, it can stay right there. So now I'm just going to total them up. I get -9 equals 3x. In order to undo that multiplication, I need to divide by 3. So -3 equals x. There you go. We're going to do lots of practice, so you'll get really good at this. Thanks.